Today I'll solve fluid mechanics numerical problem on viscosity. Here is the numerical problem. Two horizontal plates are placed 11.5 mm apart. The space between them being filled with oil of viscosity 14 poise. Calculate the shear stress in the oil if the upper plates move with a velocity of 3.5 meter per second. So here you can see the two plates. So one is upper plate, another is bottom plate, and distance between two plates that is 11.5 mm, and upper plate is moving with velocity 3.5 meter per second, and in between the two plates, so oil is filled, that oil viscosity is 14 poise. Now we have to calculate what will be the shear stress acting on the upper plate. Now the given data are, so distance between plates dy, so that is 11.5 mm. Now if we convert mm to meter, so that will be 11.5 divided by 1000, so that will be 0.0115 meter. Then viscosity of the oil, mu is 14 poise. Now we know 1 poise is equal to 0.1 Pascal second or Newton second meter square. So mu 14 poise, if we convert, so that will be 14 into 10 to the power minus 1 Newton second per meter square. Relative velocity between plates, so du ut minus ub. So ut is the upper plate velocity, ub is the fixed, means bottom plate velocity, ub is the bottom plate velocity, so that is 0 because that plate is fixed. So the du will be 3.5 minus 0 is equal to 3.5 meter per second. So that is the relative velocity du. Now we have to calculate velocity gradient. So velocity gradient is nothing but du by dy is the change of velocity per unit distance between the plates. Now here the velocity of the moving plate is 3.5 meter per second, so that is upper plate velocity, and the velocity of the fixed plate, that is bottom plate velocity, is 0 meter per second. So thus the velocity gradient will be du by dy, so 3.5 meter per second divided by dy 0.0115 meter. So now if we do the calculation, so du by dy will be 304.34 second inverse. So velocity gradient unit is second inverse. Next, that shear stress we have to calculate. So what is shear stress? Shear stress is given by the product of the viscosity and velocity gradient. So based on Newton's law of viscosity, shear stress is directly proportional to the velocity gradient. Now if we remove the proportionality constant, so tau is equal to mu into du by dy, means shear stress is the product of viscosity and velocity gradient. Now here we know viscosity is 14 into 10 to the power minus 1 Newton second per meter square, and du by dy we already calculated, so that is 304.34 second inverse. So finally if we do the calculation, ultimately we will get the shear stress. So shear stress will be 426.07 Newton per meter square. So the shear stress unit is Newton per meter square or Pascal. That's it. So we have learned how to calculate shear stress. Thank you.